The sun is there. We can get so much energy from it, but we need to make it happen. We need to deploy fast, which we are doing, but we also need to make sure we manufacture so we take advantage of that or look into our energy security.
Hi, everyone. Welcome to the Climate Confident Podcast. My name is Tom Raftery, and with me on the show today, I have my special guest, Laura. Laura, welcome to the podcast. Would you like to introduce yourself?
Hi, Tom. Thank you very much for having me here. And yes, of course. So my name is Laura Miranda, and I am Chief Communications and Sustainability Officer at Oxford PV. I have over 10 years experience in solar and more than 25 in R&D and technology. And during the last 10 years since I work at Oxford PV, I've been focusing in developing and commercializing this new exciting solar technology, which is perovskite-silicon tandem solar cell.
Okay. So give me a little bit of background first on yourself, Laura, and then on Oxford PV, and then we can get into the solar cells.
So about me, I'm a scientist by training. I started my career as a material scientist. I have a PhD in perovskite, which I know we're going to talk about that name, but I was working on this material even before it was known for solar. I was working for a few years in academia before I moved to industry, where I started looking into a way of using this or a type of these materials for solar technology. Since then, I have been holding a number of roles going from research, technology transfer, IP, strategy, management, sustainability, and then moving into more corporate roles as ESG, corporate communications with marketing, government affairs, trying to basically, I think I've been moving through my career, try to make an impact where I can. And now with what the climate crisis we have ahead, we need to deploy clean energies as quick as possible, and we need to change mindset. So I think that's where I want to put my skills at and where my career has led me to.
Great. And a little bit about Oxford PV.
So Oxford PV, it's a company founded in 2010. It has been out from the University of Oxford. So our headquarters and R&D are in Oxford. And we have a production line in Germany, in Brandenburg, close to Berlin. So what the company does is taking this new technology, which I guess we will explore more a bit later, so I'm not going to get into the details, but it's a new technology for solar that it's more efficient than conventional silicon technologies, which means that it converts more of the sunlight into electricity. What we've done since 2014, that we started with the current approach, is working in a tandem concept, which combines this new technology perovskite with silicon, increasing the efficiencies of the solar cells. And in the UK, we have our R&D. We have called them world experts developing the next generations of this technology. And in Germany, we upscale in area, but also in volume.
This is a material which, when combined with typical silicon solar cells, as you said, with your technology, it increases the efficiency of the solar panels. Typical solar panels today, if I remember correctly, are about 20% efficient, which sounds horribly low. And with your technology, that jumps up to around 30%. Am I getting the numbers right there?
Yes, there are a mix of numbers, but yes, it's more or less right. So the perovskite, it's a semiconductor material that what you have is in tandem combination. What this means is that you have two cells, one on top of the other, and they absorb complementary parts of the solar spectrum. So if you think about the solar spectrum as a rainbow, we will say that the top cell, the one that is made with perovskite that contains the perovskite, absorbs in the blue, while the bottom cells, which is the silicon, absorbs in the red. And by absorbing complementary parts of the spectrum, makes better use of that sunlight, and therefore is more efficient converting it into electricity. In terms of solar panels, it's true that the average panels install efficiencies around 21%. There exist nowadays other type of solar panels also based on silicon that can achieve efficiencies on the 24%, higher 24%. That's the limit for the current commercial silicon panel. It can still increase a bit more, but it will reach a plateau around 27%. That's the maximum that silicon could go in a solar panel. With the tandem concept, the starting point is around the top of the silicon now. So we are starting in 25% is our first product.
Mm.
We have a roadmap which will achieve 27 by 2027, 30% by 2030, and beyond that, efficiencies go higher with an upper theoretical limit that could reach 43%,
Wow.
which can never be achieved with silicon. So it's one way of looking at it is this technology comes in when silicon finishes. So it's kind of the end of the line for silicon, and then you start looking into tandem, which is the next generation of solar that will allow this better use of the sunlight.
Okay. Can you explain in very small words or very simple explanation, as if I was like 5 years old, why silicon has that upper limit of, what was it, 25, 27%?
The efficiency limits in different semiconductor materials are based on the intrinsic properties of those materials. So it's how much of that spectrum can be converted. It depends on internal properties, which are different for silicon than for perovskite and for other materials that exist. For example, cadmium telluride is also used for solar applications. So there is a combination of those intrinsic properties with other processes that happen inside the material that also limit how much of that sunlight can be converted. For silicon, the theoretical limit that could achieve as a cell is 29%. It could go up to that level. But some of that, when it goes from cell to upscale to the module, some of that is lost during the processes. So that's why the theoretical limit for a module is a bit lower. It's always limited by the properties of the semiconductor material used to convert the sunlight into electricity.
And how does it work, as in you have a layer of silicon and then on top of that you have a layer of perovskite? How is it that the perovskite allows the red light through to the silicon and doesn't absorb? I mean, is it transparent to red light, or how does the red light get through the perovskite to the silicon underneath?
It doesn't get absorbed and converted. So the way you put it is kind of that's the right thing. Is we could talk in a very simple way, is transparent to that. It won't convert that part of the spectrum. So when you get your solar spectrum hitting your solar cell and you have your two layers, in the moment it goes through the first layer, which is the perovskite, that blue part of the spectrum will get absorbed, letting the rest go through, and then it will be absorbed on that. This is based on what is called the band gap of the material. So each material has a different band gap, and depending on the value of that band gap, it will absorb different parts of the spectrum. Silicon and perovskite have different band gaps, and therefore they absorb at different parts of the spectrum.
Okay, fair enough. Let's take a step back and look at kind of a broader picture now in terms of the whole energy transition that we're going through globally. We're seeing the International Energy Agency has for several years now said that solar is now in most of the world the cheapest form of energy available. And it is being rolled out in record numbers. What do you think is the largest bottleneck still holding it back even from going faster? Is it price? Is it we fear change? Is it regulations? Is it all of the above?
I'm gonna go with all of the above, but it's a combination of factors. The energy transition, which is what needs to happen, comes from many changes. We need to see energy in a different way. We need to understand the way we use energy in a different way. We need to have different regulations. So we are coming from a centralized source of energy where we depend on fossil fuels, and they are in specific locations, and those are the sources. You cannot move the sources somewhere else, to a system in which your sources of energy can be completely decentralized. It can be in your house, it can be in your car, it can be even in your backpack. They will generate different amounts of energy, but that's how it's happening. You can have a solar farm. Obviously, there will be central points of big generating and areas for large or big energy generation, but still it will be localized. It will be in a specific area. So we are moving from centralized system to decentralized, that is highly dependent on grid connections, which we're not ready, we need to get ready. And that has to happen all at the same time. So we have grid connections, we have also sources of energy that are variable. So when you talk about fossil fuels, you can get your energy, your electricity whenever you need it at any time because it doesn't depend on other external factors. When we talk about renewables, solar, you have wind, geothermal, many sources, and more that there will be discovered because that's how we are as human beings. They are dependent on external sources. So you have sunlight, you need to have the sunlight to generate energy. You need to have wind to generate energy. You have to, and so goes the list. So you need to have proper grid connections, proper battery storage systems that store the electricity and the energy when you're not using it and you need it later in the day or in a day that there's less wind. And we need us people to get used to this different way of thinking. It's why am I going to install a solar panel in my house when I'm paying for them? Well, because you are paying for them, but at some point you will own them. So your source of energy will be that it has a return of investment. We have to learn to get used to that. We are not. So it's a combination of all of this together with new regulations. Like you just said, the political landscape is based around fossil fuels. So we need to get used to it, and we need to do it in a way that it pushes fast acceleration of the energy transition because we need to meet climate targets. That's why we are doing this. Aside of running out of resources, we need to fix the main issue we are having. And we have to do all of this at the same time in a very short period, relatively short, because otherwise we are not going to meet those targets. So it's complex, it's exciting, and it's really good to get to see this happening. At least that's my perspective working in a technology that can accelerate this. But we are living a moment that is it means a change for the world. It's just in 10 years, we will look around and everything will look different.
Indeed.
We will
Hopefully. Yeah.
have, yeah.
Fingers crossed.
Well, I'm going to keep my hope that is what it's going to happen, but it has to happen because it's happening already. There is still, complaints around, for example, you don't want a solar farm close to your area because it's destroying the landscape, but it's going to be integrated. We can see now integrated in buildings. We can talk about agri-PV combined with agriculture. It will integrate with the bio areas of the regions where it needs to be installed. It's something that we're going to see changing. We're going to see buildings with glass that generates energy. And it might not be as efficient as a panel that is on the rooftop, but everything counts. And we are going to see the world changing. And that's why what we do is so important because we can make all of that more efficient.
Yeah. And One of the arguments you sometimes hear against solar is that it's competing for land use. Now, that's obviously a rubbish argument when you compare the amount of land that's used for solar versus the amount of land that's used for golf clubs, for example. There's far more land used for golf clubs than there is for solar. But as you rightly point out, with the likes of agrivoltaics, you can combine agriculture with solar and get a dual income while increasing biodiversity as well. Do you think the fact that your solar panels, the tandem solar panels, are more efficient, is that also a good argument because they're using less land to generate the same amount of electricity?
Yes, of course. That's one of the key arguments. You can use less land to generate the same amount of electricity, or you can use the same land but generate more power.
Mm.
It depends what the preferences are. It's key for space limited applications. You think about this space. If you can use it more efficiently, it's better. So the main point of this higher efficiency, higher power generation also is that it decreases the cost of the electricity. There is now comparison is usually we go to the how much it is a panel, what's the cost per watt generated, and that's like the constant conversation, but how much it is. But that's not your product. Your product is not the panel. Your product is the electricity that is generated. So if the electricity is cheaper, it's worth it because the panel is a part of a bigger system that is generating that electricity, and having higher efficiency, what does is generate cheaper electricity. So there is an argument for cost of electricity, but also for land use. Like you say, is the conversation. We will get used to this because also it doesn't need that much land, like you were saying. If you compare with other uses, it doesn't need that much, but still there's a concern there. So if you can use less and generate the same, it could be a preferred option.
Okay. And I'm interested that you brought up cost because I'm curious, what's the price differential between a standard solar panel and one of your tandem solar panels?
Well, at the moment, the cost is so variable around the world that it's very difficult to compare with which one, because we have these panels coming from China where they have mastered the economy of scale. They've seen it. They've been working on this for many years, and they can
Mm.
build huge factories short period of time. So that has decreased the cost. I think one of the last announcements was 6 cents per watt in one of the conventional, it's not the higher efficient, but conventional silicon panels.
Mm.
That's something I'm seeing. It's the cheapest, it's never gone. If you compare the same in a European or Western made panel, and the cost increases. Our technology, without giving you the details of the numbers, is going to increase a bit the cost
Mhm.
up to a point, because it also depends on how much energy generated. We are talking about cost per watt. So it's going to be relative on how many watts can you deliver with that technology. But even with a gap, assuming that there is a gap with technology that could be more costly in the initial price, still the electricity will be cheaper. So assuming that, you will
Mm.
still have a cheaper electricity. So it's I mean, and I think it's worth it to pay less for the electricity you get.
We're seeing a lot of geopolitical tensions around the world now, the Russian invasion of Ukraine being one of the main ones that's impacting the energy scene. How do you see solar's role in energy independence and security evolving?
I mean, solar is coming back to these reducing dependencies from fossil fuels. By deploying more solar, we are reducing those dependencies because
Mm.
it's completely decentralized. But we need to also make sure we have a diversified source of solar globally. We have to avoid we are dependent on these fossil fuels from these regions, and now we are going to depend on having new solar panels from other regions because we are not able to manufacture them. So So we just need to think about how we can diversify this without getting into this, because the geopolitics at the moment are complex and are going to get even more complex.
Mm.
We're going to see a lot of changes coming. I like to see or think about this. Climate doesn't understand of politics.
Mm.
We need to make sure we deploy. We need to make sure that we diversify to avoid those dependencies. And that diversification needs to come from fast deployment from the sources we have now, but also looking into how can we manufacture more from the regions that don't have that capacity at the moment. And a way of doing that is using innovative solutions. What we have, for example, now, this technology is something that can compete in terms of manufacturing. It's a new technology. It hasn't been made at scale. You are not competing with mainstream silicon. It's
Mm.
something new that can increase that competitiveness, can strengthen the resilience and the energy security of Europe in this case, or any geography that wants to go ahead with the technology. And we will be open to work with anybody that wants to work with this technology, because we need to make it mainstream. That's our mission, is to make it happen. So this could be a way of making it.
It's good you mentioned Europe, because the EU has said they want, or we want, solar to dominate power generation by 2030. Are we on track for that? And if not, what needs to change to make that real?
We have to separate between deployment and manufacturing. So Europe has been deploying faster, but last year, for example, there was a decrease in the expectations. So it was kind of exponential increase on how much Europe is deploying. Last year, there was a decrease because there is a lack of, we were talking before about the regulations. I think the political landscape, the regulation framework needs to give more confidence to investors for a solar industry that can deploy faster and allow those investments to happen. That's on the deployment side. Still, I think we can meet in Europe those targets on solar power generation if we only look at deployment.
Mm.
But the other side is the manufacturing. Is Europe on track to meet their manufacturing goals or targets? And we're not. We are not, because we don't have a framework that is supporting that confidence. We see interest, and that's good for us, because we see interest, and even more in this technology, there is an interest. There is an interest from public and private funding sources, but there is a hold, because this situation is dynamic. It doesn't inspire the confidence of creating something that is stable, that will allow investors to say, yes, go ahead, and we will support this manufacturing. So we need that. That's what we were discussing, I think, at the beginning, Tom, is we need all of that, not just for the transition, but even for solar. Solar is at the core of the energy transition. It's at the center. The sun
Mm.
is there. We can get so much energy from it. But we need to make it happen. We need to deploy fast, which we are doing, but we also need to make sure we manufacture, so we take advantage of that, or look into our energy security.
And if, let's say, things go really well for you guys, if your perovskite on silicon cells were adopted worldwide, what kind of emissions reductions do you think we're talking about?
If we talk about linear, which is never linear, but if you think about our first product will produce at least 20% more power than conventional silicon, it will be 20% reductions just from that linear approach. Obviously, it
Mm.
also depends on how do you manufacture, how do you make your panels. So we have some estimations that our technology will be at least 7% emitting less in the manufacturing process than the conventional one. The more efficient it gets, the more is reduced. It's not linear, but we can expect at least starting by 20% less emissions. That is comparing with already clean sources of energy.
Yeah.
It's not about that. Because we never compare with fossil fuels because it's obvious that, of course, the emissions will be lower.
Mm.
So we try to compare with something that makes more sense. But in reality, what we need to do is compare with fossil fuels. The reductions are, well, like with solar or energy, any renewable, because in the moment you have emissions during the manufacturing. In the moment those panels are installed is clean energy without further emissions.
Mm.
The more solar gets deployed, the more renewables are deployed, you can run those factories with clean energy, which will lead to a net zero or zero emissions manufacturing processes. So that's what is to be expected. Yeah.
Yeah. And you guys announced recently your first commercial deal in the US. What's the feedback from utilities? Are they excited or skeptical or just waiting for someone else to jump in first?
Yeah, we ship it to it was a utilities customer, and that was a very interesting process for us because when we started working on the technology, when you think about the type of product you have, space limited, as we were discussing, we thought the first interest was going to be coming more from a residential or CNI market. But it hasn't been like that. We have a lot of interest from utilities or customers in the utilities market. They want to try it first. They want to see how the technology works. They want to work with us to get those panels first, having first access to them, install them, see how they operate. And it's fantastic to see all of that interest because at the end of the day, what they are working also is on the same premises and that we are saying is the cost of the electricity generated. That is what makes it worthwhile. We have a lot of interest from all the markets, all the areas. And at the moment, we are working with the utilities customers that come kind of first come, first serve, because we don't have enough volume to do everything as I would like, we would like. We have interest now also in the residential market and also what we call the specialty markets, which is anything that is not mainstream.
Mm.
So you think about these technologies, not just the power per area, but it's the power per weight. So
Okay.
we talk about automotive, we talk about space, we talk about high altitude platform systems, transport, anything that you can install a technology, a solar system that is more efficient, that also can deliver more power per weight, it will impact what
Mm.
it can happen. So it's a full integration. That's the way we are working with our technology. We know it can make an impact, not just in utilities, not just residential, but also any other application where higher power will have an impact. And I honestly, I don't see any application that won't be a thing.
Fantastic. What about things like longevity and recyclability? How does perovskite solar compare to traditional solar panels?
We've been answering this question, I think, from the 10 years we've been working on the technology. So, starting with recyclability, we're working with third parties. We have got a lot of internal work understanding how it behaves. Is it different? Do we need to do something about it? Last couple of years, we were working with third parties, and the tandem modules can be recycled using exactly the same processes that exist in the industry. So there's nothing extra to do with them, regardless of that extra perovskite cell. It can be taken end of life, same routes than mainstream silicon panels. Now we are also working in improving this, not because of the technology, but because we think it's the way to go. Solar should be as circular as possible, as
Mm.
recyclable as possible. So we want to increase the percentage of materials that you can recover at the end of life and potentially reuse them. Or if it's not a solar application, at least something on the clean tech space. So you have a circular approach that is based on clean systems. There were some concerns about that, but we have tested, sample, analyzed our modules, and they come with the same classification as mainstream ones, and they can be treated in the same way. So there's no concern at all on that in that sense. Not that we are going to stop working on it, but at least the first set of results are very positive. And in terms of longevity, of course, it's a new technology. So if we make a separation between applications, at the moment, what we are doing, we are meeting any requirements from our customers. So anything that they require from us for the technology, that's what we are meeting. So there hasn't been any concerns around the longevity of the technology. Each application has different requirements in terms of how reliable it needs to be. And that's the way we are operating. For each application, we need to look into what is required and then amend, work on it, and develop in that sense. The way we work at Oxford PB is we work in efficiency at the same time that we work in stability. So we don't just beat world records because its efficiency is higher. We work in increasing the efficiency at the same time that we increase the stability of those new generations to make sure we have a product that is reliable and meets customer expectations.
Obviously, you mentioned that you're needing to scale up production to meet demand, which is a nice position to be in. But what are the biggest hurdles in moving from the lab to mass deployment?
The challenge is you have to go from small lab scale to mass production. We have already gone through them with our factory in Germany. If at this point we can build a factory, we know how to do it because we went through it. Now we have the challenges to do that when you move from a very small area cell done in a lab that doesn't look now like it looked a few years ago to, let's say, pilot line manufacturing tools that are equivalent to what we will call a production tool. It's not the same, but it has the same specifications that you can design. So one of the good things of these technologies, it's compatible with existing manufacturing processes. So we didn't need to develop anything new to make a product. Still, you need to tune it, you need to understand it, you need to learn, even with an existing process, how do you tune it to meet what a product should have, what a operating line should do in terms of throughput, for example. So there has been a lot of learning into upscaling from a small area to large area in terms of how do you control those processes, what are the key parameters of existing processes. And that's what we've been doing for the last, when we bought our factory in Germany, it was 2016. So since then, that's what we have been doing. And now we do have a very good understanding. So we could do the jump into mass scale production with a very good view of what needs to be done and what tools do we need.
Okay, and why Germany? Why not beside yourselves there in Oxford or in France or in Norway or in Spain here or why Germany in particular?
Spain would have been nice, but no, we look everywhere. At the time, we were just looking into a site that could meet our needs in terms of space, obviously cost, support, local support, and we were looking everywhere around to see. We look in the UK, and our CEO at the time was German, so obviously Germany was a place to look at. But it wasn't just because of that. It's because there was an existing solar factory there from Bosch.
Ah,
They have equipment, they have infrastructure. So it's not that it was perfect. We had a lot to do there, but there was a very good starting point. And
mm,
that came together with strong local support from the region.
ah,
So it was a combination of the right place, right sites, level of support. So that's how we made the decision. It wasn't location driven, but the other set of factors help us taking the
yeah,
decision.
okay. And a lot of people think of solar as rooftop panels or massive solar farms from utilities. What would be, in your opinion, the most unexpected application of your technology that you've come across?
I'm not sure because solar is integrated everywhere.
Mm,
So we are gonna see it. That's a bit why I'm not sure if it will be unexpected or more the opportunity with the technologies that you can make more out of it, rather than because it's a different technology, you can have different applications.
Mhm.
It's more you have a system that can give you most out of the applications in which you are using it. So, for example, if you think about EV cars, you can extend the autonomous range. If you think about these high altitude platform systems, you can fly to higher latitudes with better monitoring for scientific or environmental applications, better connectivity with remote areas. Um, Satellites space, you can reduce the production cost and the launch, which is one of the key factors in that market. Um, Wherever you use it, it will have an impact because you get more out of it with the tandem technology. One thing we haven't discussed, because that's not something we are doing now, but the future will see perovskite only technology. So you won't need the tandem with the silicon. You can have a tandem with two perovskite cells, or even three perovskite cells,
Wow.
which will change completely because that could be a different type. It's a thin film. It could be used in different ways, different applications. Those type of technologies exist. This is not new, but the efficiency that you can achieve will be much higher, and that will allow us to see it in other applications. I don't know, even in water bottles if you want to, or in thermos to keep the liquid inside hot. So we'll see it, but at the moment it makes you rethink how to use solar because you can make out more out of it. So it's unlocking different ways of using it.
Oh, fascinating. And what's one misconception about solar energy that drives you crazy and you wish people would stop repeating?
I have two. One is that when it's cloudy, solar energy doesn't work because it does. And yes, the efficiency might decrease, but still you get enough to power what you need to power. So that's one of them. And that comes because being living in the UK, you get cloudy days, and that's a misconception around here. You know, it's about because in the UK won't work. Well, it will.
Mm.
And the other one, and we discussed it already, is this land use. But it's because it's a question of perception. It's a question of understanding how much land do you really need to deliver the power that it's required. And I think those are the two things that well, I have another one that is
Okay,
in sorry. I just
go.
it's because there's a bit of discussion around, and maybe this is just within industry or people that knows the industry, but if you keep deploying solar by 2030, 2050, when those solar panels start working, the amount of waste it will be really high, and
Mm.
you need to manage, which is true, but it's nothing compared with the waste you get from your plants that are using fossil fuels, common waste. So it's all about perspective. Yes, there are going to be a lot of solar panels that will have to be recommissioned, reuse, recommission, recycle, but that's what we need to work towards. But it's not because it's a huge source of waste. It's because we need to think about circularity whatever we do. We need to change the mindset.
Mm. Fair enough. Fair enough. If you had unlimited research and development funding for one futuristic solar related project, what would you build?
One of our colleagues, this was many years ago, but he told me, imagine we could have clouds made of perovskite that they are generating energy.
Wow.
I'm not sure if this is something that even can be done because obviously we're talking about connections, etc. But could we have some way of, outsourcing that energy generation to externally? One other thing that I thought was, and I really like, it's not new now. I've read that somebody's looking into it, but it's the moon
Oh, yeah.
solar panel because obviously sun reflects on the moon and then you can still get some sunlight there. I don't know how if that can ever work, but you know, the world is
Yeah.
changing. We may not see it, but there are
Mm.
big things that are going to happen, and we're going to see some of them. So
Yeah.
it's an exciting time.
Yeah, China has announced that they're going to build a Three Gorges Dam type solar plant in space. So, and the Three
Why not?
Gorges, yeah. The Three Gorges generates around 20 gigawatts. So, if they had a 20 gigawatt solar power plant in space, that would be pretty impressive. Obviously,
Yep.
getting it to space is one problem, but then getting the energy from space back down to Earth is the next one. They said they're going to put it in geostationary orbit, so be it 36,000 kilometers. So
Okay.
that's a very
Good
long
luck.
power line, or or they're using microwaves, I guess.
Yes. Yes. It's like a very long, a very big balloon
Yeah,
floating
kite.
and with vehicles. So yeah, it's see, I was it's not a cloud, but it's similar. It's
Yeah,
we're gonna start looking at ways of making things different. It's let's see. I mean, I would love to see that.
yeah.
I don't know how it
Likewise,
can work, but I would love to see it.
likewise. A left field question for you, Laura. If you could have any person or character, alive or dead, real or fictional, as a spokesperson for perovskite solar or a champion for perovskite solar, who would it be and why?
Um, wow, it's so many. I can go from fantasy to
Yeah.
characters, but I mean thinking very fast, and it's gonna sound like a cliché, but it's not. I think I would love to get Michelle Obama
Huh?
working for us and being a spoken person because I read her book. It's not because who she is or the role she's playing, and even it's not that I'm completely updated on it's not that I'm fat, but the way she talks, the enthusiasm and her way of looking at things, I think it would be a very good advocate for a new technology because what we need to do is the risking it.
Yeah.
Is we are very risk adverse in general, and we need somebody that can de-risk it, that can support it and say, well, yes, you have to take a risk, but we know enough now to know that it will work and it's the future of solar. So
Mm.
we need somebody that can have that enthusiasm to help us driving the message.
Fantastic. Great. Okay, Laura, we're coming towards the end of the podcast now. Is there any question I did not ask that you wish I did, or any aspect of this we haven't touched on that you think it's important for people to think about?
No, I think we covered quite a lot. I cannot think about anything else.
Okay. Okay, fantastic. In that case, Laura, if people would like to know more about yourself or any of the things we discussed on the podcast, where would you have me direct them?
No, they can. Well, there are two ways. They can go through our website, which is www.oxfordpv.com.
Hmm.
We have also LinkedIn's social media site.
Hmm.
If they want to reach out to me directly, also they can do it through my LinkedIn. They can contact me there, send me a message.
Sure. Sure. I'll put those links in the show notes as well, so everyone will have access to them. Fantastic.
Yep.
Okay, Laura, that's been really interesting. Thanks a million for coming on the podcast today.
Thank you, Tom. It was lovely. Thank you.